All right, so this is 6-9 worksheet. We're going to do the front page, middle or left, and front page, bottom right there. Very similar. We have no quotient rules. And so your one option is to multiply all this out, but that still ain't going to be any good. And up here, you got a cube root of this deal. So the first thing you want to do up here is rewrite this without the cube root. So we're going to rewrite this as x. And then down here, I'm going to make this x squared plus 1 to the 1/3 power dx. And down here, we're fine the way we are. So we don't have a quotient rule for integrals either. So we have to manipulate what these look like in order to get into one of our rules. Now, because this power is not a nice little 1, and because I see that if I let u be this denominator and I do the derivative of x squared, it'll give me an x like it's in the top that I need. That's what I'm going to do. When you have some kind of power, you usually want to let u be the part inside. So I'm going to let u equal the part inside the parentheses. And when I do the derivative of u with respect to x, I get 2x, and you move your dx over here with it. Because I need to get du where the dx is. So I need to have a 2x dx to plug that into. So if you look over here, I am missing the 2. I've got the x dx, but I don't have the 2. So I have to create a 2. And I have to destroy the 2. So when I rewrite this plugging in my u stuff, I now got a 1 du for the top part because I get to plug du in for all of this stuff. And down here I got a u to the 1/3 power. Now I can simplify this without a u in the bottom by moving it to the top and making the power negative. And now I can use my power rule. So my power rule says that I can take, and you just leave that coefficient half out front the whole time. It says I can add 1 to negative 1/3. So adding 3/3 to negative 1/3 gives me positive 2/3. And you divide that by 2/3, or you can take and flip it over and multiply by the reciprocal in one step to get rid of the compound fraction. You are not allowed on these. Now this is an indefinite interval because there's no intervals here, and you got to put a plus c there if it is one. But you're not allowed to leave these with u, so I got to come back up here and plug this back into the u, because if I start with an x, I got to end with an x. So this will equal, and I'd multiply these fractions in front together and get 3/4. And then I got my u, which I'm going to stick 3x squared plus 1 back in, and then leave my power 2/3 plus c. Now you could leave it like that, or you could put it back into a radical, which is a cube root, so you need your 3 out here, and you got your x squared plus 1 here, and you'd have that squared. I don't know how they're going to write the answer. They might write the answer like this, or they might write it like the one below. You need to be able to manipulate radicals. This problem is extremely similar, because I got a deal in the bottom to a power of, is that a 3? Okay, so I'm going to let u equal the part in the parentheses, just like I did up there. And my du then has to equal 8 dx. Well, I got my dx right here, but I'm missing the 8. So I got to create an 8 and destroy an 8. So now I can rewrite this as 1/8 integral du. I like putting 1 in top and putting du over here. You can put the du in place of the 1, it's okay. And then I got a u cubed down here. So now it's very similar to where I was right here. So I'm going to take that u cubed in the denominator and move it to the top. And then I got to add 1 to negative 3. So when I add 1 to negative 3, I get negative 2. I got to put that over negative 2. Then I got a plus c. Then I got to take my negative 2 times 1/8. The negative 2 is on the bottom, so this will end up being a negative 1/16 in the front. And then I would want to put that u squared back in the bottom, but I'm going to stick this 8x minus 1 back in for it. And that would be your answer right there. Question on that. You see how they're very similar? The only time you're going to get natural log in your answer is if the denominator is just an x to the first power or u to the first power. All the rest of the time, you're going to move them up and do power rule. Anybody got any other problems you want to see on 6-9 from any of it? Okay, let's pass those up to the front. Like if I take 7 divided by 3. If I do 7 divided by 3, I get 2. With a remainder of 1, I get 2 1/3. This thing is equal to that thing. Those two things are equal. It's going to be the same story here. So if I take the bottom, or the top divided by the bottom, I got x squared plus 4x plus 0 divided by x squared plus 4x plus 13. I ask myself, what times x squared gives me x squared? That's 1. When I distribute 1 through that whole thing on the outside, I get the exact same thing here. Now the problem with this is a lot of people forget to subtract. We are subtracting this whole line. Because back over here with numbers, we got so used to it, we quit writing in the minus sign. And you just knew it with subtraction. So these first two things reduce, and my remainder is negative 13. So I can rewrite this as 1 minus 13 over my divisor, just like I did over here with this 2 1/3. So it's the same thing as numbers, but I just have variables in there. So that thing in blue is the same as this thing as a fraction. So I'm going to erase this and do the work right here.
Now you can integrate it.
So that's right, I have to integrate that thing. And these are kind of tricky, especially the second part. The first part I hope is easy. I'm going to do the integral of 1 dx, just like always. Then over here, I'm going to take that minus 13 out in front of the integral because it's coefficient and get 1 over x squared plus 4x. And I'm going to cheat because I know I did this last period, so I know what I'm doing here. I'm going to that plus 13 over here. And this is so complicated. If I let you, like that last problem we did on 6-9, if I let u be one of this bottom, I'm going to have a du that equals 2x plus 4. Do you see I don't have any x's up here? So that tells me I can't use that method. So the next thing I got to think of is, well, what kind of a functions do I have that has 1 all by itself in the numerator and stuff down here? And that's some of the arc stuff. So if I complete the square here, like you did back in Algebra 2 and pre-cal, you take half of 4, which is 2, and squared, which is 4. So you add 4 there, and you come out here and you subtract 4 because you got to keep these two things equal. So even though I changed the way it looked, they're still equal. Then up here, I'm going to go ahead and do the integral of x, or sorry, integral of 1, which is x, and I still got minus 13. And then I'm going to rewrite this thing by factoring it into squares because arctangent does not have anything in the numerator, and it's got 2 squares on the bottom. Well, I've only got 1 square, but what's real nice about 9? Isn't 9 3 squared? So I can rewrite that as 3 squared. The constant from the formula is your a, and the part with the variable inside there being squared is your u. So then you're going to get x minus 13, and then this is arctan because there's no radicals. I know that one's arctan because there's no radicals. So I'm going to use I forgot it's 1 over a first, so it's 1 over 3, and then it's arctan. I probably should put parentheses here because it's times that negative 13. And then I got arctan, which is the same as inverse tan. You can either write arctan or inverse tan, and it's your u over a plus some c. So the last thing you would do is just multiply that. I don't need the parenthesis out there. Parenthesis should go right here. Okay, so you take negative 13 times a third. They probably write it like this in the book or in the multiple choice part. And they may have the word arctan there instead of tan or inverse tan, but they're the same. And that right there is what we're looking for. Those problems are pretty hard, I think. Okay, we're going to go on to the next one. We're going to see that. By the way, that was already on video. And we said 8 and 10. Is that what we said back here? Okay, so we're going to do 8 first. So now this one, now see, I'm happy about this, kind of. Because it looks like if I let u be the bottom part, I got a 2x here, right? So let's see what we want to do here. So I'm going to say u equals x squared plus 6x plus plus 13, which means du is going to equal 2x plus 6. Oh, that kind of stinks. Because I don't have a plus 6 there, do I? I just got a 2x. Well, could I add 6? If I added 6, what else would I have to do to keep it equal? Could I add 6 and subtract 6 and be equal? So that's what I'm going to do. I'm going to say, well, plus 6 and then minus 6 is going to be the same. Now, this is all over the same denominator. Okay? So I'm going to now write this as two different problems. I'm going to write this as the integral of the 2x plus 6 part, because I need that because of this part right there, all over my x squared plus 6x plus 13 dx, and that's going to be one problem I do with this u du thing. And then over here I got a minus 6 over this same denominator, which is x squared plus 6x plus 13 dx. So this is a combination deal. This is old u substitution, so I'm going to do that now. So this is going to be 1 over u du, because I put u to be this bottom part, and this top part is du. And again, if you want to put the du up there, you can, but I like looking at it like that. And then over here, I would bring that minus 6 out. Probably should have done it first, and have a 1 here. Now, does this look familiar to something we just did? A number over a bunch of stuff in the bottom? So we're going to complete the square again on this one. So this is still going to be the integral of 1 over, and then I'm going to complete the square of x squared plus 6x. And you take half of 6, which is 3, and you square it, so you get plus 9 there. And we move that plus 13 over again. And then I subtract 9 there to keep it equal. And now I'm gonna go ahead and do the integral of 1 over u. Do we all know what that is? That natural log of the absolute value of u. Then I still got minus 6, and I need to factor this stuff. So I got 1 on top, and this would be x plus 3 squared plus 13 minus 9 is 4. Well, I know 4 is 2 squared. Now, does that look familiar to what we just did?
Arctan.
It's arctan again. So over here, I'm going to plug in my x squared plus 6x plus 13. Back in for the u, because you want your answers in x values. And then I'm going to do my 1 over a times the arctan, or inverse tan, of u, which is x plus 3, all over a, which is 2, and then that's plus some c. And you should probably go ahead and reduce that negative 6 and 2. So that's a long answer, man. So 6 and 2 reduce this to negative 3 arctan, or inverse tan, of x plus 2 over 2 plus a c, and you're done. Question on that one?
Question.
Yeah.
Why do you always have to put absolute value with log?
Okay, we need the domain for logarithms. If you graph a natural log or a logarithm, they all do this right here. Okay? This is the y-axis. It's an asymptote. So when you do a log, your domain is 0 to infinity. So when you do a log or a natural log, 0 doesn't count. You can't do the log of 0 even. So the reason you put absolute value here is you're telling the world that this number has to be a positive, because natural log does not use 0 or any negatives.
Okay, so
Okay.
if you put in like -1, it will not work.
That's, well, -1 will work. I'll still, as a matter of fact, any value will work on this, because
Oh.
I think, let's see, 2, 3, let's see, if I put in -5, 25, yeah, that still works. -4, 16, 20, yeah. Yeah, they'd all work here. This number right here is positive no matter what.
Okay.
Yes.
Why is it x plus 2?
Say again.
Why is it x plus 2?
Oh, because I screwed up. It should be x plus 3 here. Yeah, that should be an x plus 3. Thank you. All right, we're going to do this last one, and then you're going to have a quiz. So we got this deal. Oh, this is in a radical now. Anybody know what radical makes me think? This is going to be an arctan. It's got a 1 on top. Arcsecant or arcsine. So we need to complete the square here and see what we get. So before you complete the square down there in the bottom, you're going to have to factor out a -1 inside the radical because you want to complete the square with your leading coefficient. You want your leading coefficient to be a positive. So now this one's going to get a little ugly. So I got to take half of 1, which is a half, and square it. So I got to add 1/4 right here. Now that right there looks like we just added a 4th, but in reality, we have to factor negative out to complete that square, right? So if I take that negative times 1/4, I didn't actually add 1/4 there. I actually subtracted a 4th because of this negative sign. So what that means out here is I got to put plus 1/4 to keep it equal. And then when I write this in factored form, I'm going to have 1 in front. Now this 1/4 part's the positive part, so I'm going to make that 1/2 squared, and it's still in the radical. Minus, because that minus sign is right there, x plus 1/2 squared. Now, what form has an an a minus u squared? A squared minus u squared in a radical. Which one is that? So this is an arcsine problem. So we're going to get the arcsine. Let's see, du over a, right? I better check. I want to make sure. I went blank there for a second. Is it u over a? I don't think we have anything over a in the front, do we? I think it's just u, which is x plus 1/2 over 1/2 plus c, right? Isn't that it? Now, you would probably want to multiply the top and bottom here by 2 so you don't have a compound fraction. So if you multiply that all by 2, we'll end up with arcsine or inverse sine. And then on the top, we would have a 2x plus 1, and that'd be over 1 because those reduce, plus c. That's probably how they would write the answer on that one. Questions? Okay. So I need you to take your 610 and pass it up to the front.